So if you just walked in, Chapter 0, Concept Review, is due at the beginning of class Friday. And we'll come back to it and try to knock some of that out. Yeah, that page. We'll come back to it and try to knock some of that out if we have at the end of the hour. This Chapter 1 is also due at the beginning of the hour on Friday. Okay, this Chapter 1 Concept Review.
First page.
The first page, okay. And then there's a third thing that's due. If you take a look at the next page, okay. Start at Chapter 0, very first page, due Friday. Flip it over, due Friday. Flip it over. It says read. So that means there's bold words that are going to be due.
What does it say read?
It says read sections 1.1 and 1.2. Flip it over.
Oh, so this is due Friday too?
Yep.
All 3 pages?
Keep going. Keep going.
All the way through 6.
4, 2.
There you go. All right. All the way through 6 is due. Thank you.
Okay.
Right? And then it has a read. So in all parts where it says read, you have to provide handwritten definitions of all bold words that show up. So you can copy what's in the book. You can Google it. It doesn't really matter. So all that stuff will be due Friday. Unless we hit some real big roadblock and something's really confusing in these concept reviews, and then we'll stop and say, we'll finish this. Okay, but let's see. Hopefully you guys remember a lot of this stuff.
So and then we do these problems on here too?
No. Just stop at the read.
Oh, okay.
Stop at the read. Because then we're going to talk about all that stuff, and then we'll do some we'll see how far we can get in the problems. And what we don't finish, that'll be homework, along with the next read for the next section. And that's what we'll keep doing until we have an exam on that chapter. Then the whole thing starts over again. We'll have a concept review. Make sense? Okay. Speed and velocity. Shelby, what's the difference?
Velocity, speed based on distance, and velocity is based on.
So maybe let's start with this. What are the units? Let's start with this one, maybe.
Oh,
What are the units of each?
meters per second squared.
Meters per second.
And
For velocity.
Oh, time.
Isn't it speed? Meters per second too, or no?
yeah, they're both meters per second. Mm-mm.
Acceleration.
Ooh, that's a good one. Meters per second. How is your speed increasing or decreasing every second? That's meters per second, which is meters per second squared, and that's acceleration with usually what little variable?
Time.
What little variable do they use to represent acceleration? Little a. That's little a. Okay, so we're talking about the v. Speed or velocity. It's that little v. Has the same units. If it has the same units, what's the difference, Jeff?
Speed is a scalar, velocity is a vector.
Ooh, man, he remembers his physics, right? One's a scalar, one's a vector. Now, what's the difference? He's still using Gloriana some physics terms here. What's the difference between a scalar and a vector?
Vector has direction.
Vector has direction.
I was gonna say that.
Vector has direction. Which one has direction, speed or velocity?
Velocity.
Velocity has direction. So if I'm going 50 meters per second towards Austin, that's velocity. If I'm going 50 meters per second and I stop talking about stuff, that's speed. Standard metric unit for energy. Kelly, what's the standard metric unit for energy? Joules. And how do you abbreviate joule, Kevin?
J.
Big J. Okay, what are the metric units that make up this unit of energy? So the fundamental metric units, Melissa, that make up a joule. Yeah, but not mass. You have to. For mass, wouldn't be mass. It'd be kilograms. Okay, now she might. For me, there's only one way for me to do this because I don't memorize jack. So what I do is I do the concepts. I do logic. I know that. I guess I memorized this as jack. What's that equation? Work is what times what? Force times distance. Work has what units? Joules. So if I just know the units for F and I know the units for D, I can figure out the units for joules. So, but I need to go further. Because F, the units for F is what? Newtons, big N. But that's not a fundamental unit. It consists of other things. So what did F equal? Mass times acceleration. Right? But so that's my F part, and then I got to do my D. So work is mad. Now you can plug in all the standard metric units, Alyssa. What's the standard metric units for, answer's getting long. So this is a joule.
The mass is
Kilograms,
acceleration was
meters per second squared,
and then D was distance.
meter, which is meters. Meters. Standard metric unit for distance is meters. The only one that's funky is mass. Standard metric unit for mass is kilograms. And why they did that, that's the only spot in the metric system where they screwed up, in my view. Because everything else is just a base unit. It was awesome. But, okay, so it's really not, the best answer would be a joule is a kilogram times a meter squared per second squared. That'd be the best answer you could give. I don't know how much notation you guys did in your calculus courses, but what's the difference between that symbol and this symbol? This is a definition. This is a mathematical equal sign. Yeah, so this is a definition. A joule is defined as kilogram meter squared over second squared. Very good, Alyssa. That's brownie points. Okay. Standard metric unit for pressure. Kelly.
I was going to ask you about the joule.
Uh-huh.
Equals. Is it like the equals and then like a curved line?
Oh, no, it's just 3 lines.
Oh.
That's how, instead of writing as defined as. Because technically, this wouldn't really be correct. Right? Because they're expecting numbers when you see equal signs. So technically, that's correct. 3 lines defined. Good. Stop me anywhere along here. You have a question. Standard metric unit for pressure, Eric.
ATM?
Mm-mm.
Millimeter mercury?
Mm-mm.
Pascal?
Pascal.
I don't remember that at all.
Pascal. What are the units that make up this unit of pressure? Okay. So I think for you to figure out what these units are, you really got to know what pressure is, Shelby. What is pressure? This is going to be a bad spot all semester, Eric. I'm exerting pressure on this guy. Yep. I'm exerting more pressure on this guy. Here, now what's weird is I'm exerting even more pressure. This is going to start hurting, but he's got a high pain threshold, so he's not saying anything. Force per unit. Look at this really dinky spot here. Force per unit area. Pressure is force per unit area. That's how you figure out what the units are. You got to start with the physical expression for pressure. Okay, so if pressure is force per unit area, that would mean that ooh, here's another one. An equal sign with an arrow implies. Pressure is force per unit area. So that implies that pressure is defined as, okay, good. Newtons. Oh, we can put that in. Well, we could just jump right to it. Instead of writing a Newton, we want the fundamental metric units. So instead of writing a Newton, we could write kilograms Maybe we should write a Newton first. Area is meter squared. Okay. Now it's here. I guess we should still stay with defined. What's a Newton? Force.
So
MAD was work. Force is Newton's second law. F equals MA. Okay. So that means a Newton has to be a kilogram times what? Meters per second squared. And all that's divided by meters squared. So you really end up with good. You end up with kilograms all over meters second squared. Right. Okay. In equation 9, oh, here it is. Here's equation 9. C rel has units of speed. R has the gas constant in metric units. T is the temperature in Kelvin. M is the molecular weight. Use equation 9 to clearly show how all the units cancel, leaving the units for speed for C rel. Okay, so what are the units for speed again, Kevin? All right, so what we're wondering here, I'm going to put a question mark above it or something. Right, is this going to work? Let's put in the units for all this stuff in that equation. So, Mel, are there any units here? No units square root of 2. Keep going. What's the 1/2 mean, Alyssa? Square root. So we're going to take the square root of this whole mess. Any units here, Eric? The 8? No. Ooh, the R. Okay, Shelby. Metric units for R, the gas constant. Now, the one that we used a lot, if you remember Gen Chem, it was 0.0821. Plugged in this calculator a lot. Do you remember what it was? 0.0821. What were the units that went along with that 0.0821? This is because we never used the metric one.
Liters, atmospheres per mole Kelvin.
Liters, atmospheres per mole Kelvin. That's the one we used all the time because it was so convenient, right? 0.0821 liter atmospheres per mole Kelvin. That means volume had to be in liters. Pressure had to be in atmospheres. And then temperature had to be in Kelvin. And then you had to have moles. And that was so convenient because that's what we always had our units in. We never, ever, hardly ever, ever used the metric one. What's the metric one, Gloriana? Now, all these constants are probably in your inside front cover of your book or something. Or if you look at the end of, let's take a look. At the end of this chapter 1, you hopefully have an equation sheet. Let's see. Yeah, there it is. It's on page 13. So that's what I'm giving you for the first exam, is that page 13. So if it's not on there, you better know it. Is what we're looking for, Gloriana, on that sheet? Yes. What is it? What are the units?
Liters.
But we want the metric ones.
I'm sorry, what?
We want the metric units for R.
Isn't it liters?
But liters isn't. Well, let me help you catch it here. Liters is what is unit of what? Volume. What's the standard metric unit for volume? Is it liters? For volume. What's the standard metric unit for volume? Mm-mm. You're getting closer though.
Square meter.
Square meter, it would be area.
Sorry, cube meter.
Cube meter. Because volume is defined as what times what times what? Length times width times height. Well, that means you have a distance times a distance times a distance. Well, what's the standard metric unit of distance? Meters. So the standard metric unit of volume has to be cubic meters. And it's just something that we're going to have to get used to. But it's really going to save our behind if we just stick to standard metric units. So I'm not going to let you go that easy, Gloriana. Okay. So what are the standard metric units for the gas constant R? Did I give them to you? Are they in that? Are they on that sheet, or is it something we have to memorize? Because, well, you can. It's a cubic decimeter actually is a liter. You see the bar? That's definitely the English system or some funky system, right? But look at the joule, Kelvin, mole. Well, really, it's a joule per Kelvin per mole. Kelvin, you've got your standard metric unit for temperature. Mole, you've got your standard metric unit for amount of a substance. Joule, that's a standard metric unit for what? Energy. So that joule per Kelvin per mole, that's it. The gas constant has units of energy in it, per unit temperature, per unit amount. So the standard metric unit for the gas constant, I gave it to you. It's that joule per Kelvin. I wrote it in the bottom, so I'm not going to write a -1 there. Per Kelvin per mole. All right? I'm supposed to be taking the square root of this mess. I should probably use brackets, right? Because it's inside the square root. This is getting hard to see here. I need more space. Whoop. All right, just start again here. Okay, meters per second. So all this mess for that equation, right? It's all inside the square root. So I better have my square root thing going on here. I've got a top and a bottom. And we said that R is a joule per Kelvin mole. Right? And it's just R. It's not R squared. I just plug in those units for it. T, Jeff. Standard metric units for T. That's the next guy. Standard metric units.
Celsius.
Kelvin. R was kind of a hint, because if R is in the standard metric units, it had Kelvin in it. So it has to be Kelvin. So that's up on top. And then I have in the bottom I have a pi. What's pi? Pi is also osmotic pressure. I don't think that's, I think it's just 3.14 in this. So just leave it alone. M. Big M is, oh, did they tell us what pi was? It's not in here. I should have that in there. I'm pretty sure it's just pi. I thought it was osmotic pressure. Okay. Big M is molecular weight, right? M is a molecular weight. Standard metric units for molecular weight. Has to be standard metric units, though. Kilograms per mole. Okay, so the idea here is we got to make sure this is going to work out and get meters per second. But the point of why we're going through all this is you see the trick to solving this problem and getting the right answer in the back of the book. You're going to forget to put what in kilograms per mole, assuming this is going to work out. The molecular weight. You can't, oh, okay, here's our molecule. Oh, we just add it up on the periodic table, put it in the equation, that's my molecular weight. No, you're off by 1,000. This has to be standard metric units if you want to get meters per second. Well, let's verify it, though. Okay, so we already said a joule was this. We had meter squared. Oh, I forgot my kilograms. Shoot. Kilogram, meter squared over second squared. And I've got my Kelvin. Right? And I've got my Kelvin. And I've got my moles. And I've got my kilograms. And I've got my moles. And I got to take the square root of this whole ugly thing. So check it out. Make sure you get meters per second on both sides. Yeah, so pi was just 3.14. Yeah, you want to show that you have meters per second on both sides. So, like, those kelvins cancel. That mole cancels with that moles. This kilogram would cancel with that kilograms. You'd be left with what inside the meter squared over second squared? But it's square root, so it works. So it works. So that, to me, is the beauty of the metric system. It's going to save our behind a lot. Just put everything in standard metric units, no matter how weird it sounds. Volume has to be in what standard metric units? Meters cubed. So that's life. What's the equation for volume of a sphere, Kevin? 4/3 pi r cubed. Perform each of the following conversions. Clearly show our work. Draw a box around final answers. 1,300 cubic centimeters to milliliters. Remember doing the whole big box thing? You want to end up in milliliters. Okay, Kelly, how do you do this? Yeah, centimeters cubed has to go on the bottom. You're right. It's a good start. You know they got to cancel. Milliliter goes up on top. What's the ratio? 1 to 1. 1 milliliter is 1 cubic centimeter. So, right. 673 cubic centimeters to cubic decimeters. You know, I abhor memorizing so much that I just have these minimum things that I have memorized. Like pressure, I know it's force per unit area. You could, I'm pretty sure there's 10 cubic decimeters, perhaps. No, maybe not, because they have to raise it to a power. But I know that the ratio centimeters to meters, decimeters, and meters, those are the ones I have down. 100 centimeters in a meter, 10 decimeters in a meter. I can't screw that up. And it takes a second to write it. So why not just do it this way? And there's no way I can screw up. I just got to remember to do what? Cube this stuff. And there's no way I can screw up. So if you put the, all right? Yeah, so I don't know, what would be the ratio? You got 1,000, 10 to the third over 10, 10 to the fourth. You should have a 10 on, you'd end up with a 10 on the bottom. So there's what? 1 decimeter is, I don't know what the hell that means. 10 centimeters? Yeah, 1 decimeter would be 10 centimeters, if you could remember that. But why memorize it? Just do it this way, okay? So it's a lot easier just to do it this way. How about, okay, but I think you got the idea, so you can probably finish these, right? Let's do one more.
So that one should come out to.
So you're going to have 673 divided by 100 cubed times 10 cubed. Or you could have, this is 10 to the second. You'd have 10 to the sixth down here. You'd have 10 to the third here. Oh, it's 1,000. You'd have 10 to the third down there. Right? You end up with a 10 to the third. So there's actually 10 to the third. There's actually 1,000 centimeters, 1,000 cubic centimeters for 1 cubic decimeter. Right? But to me, just, you don't mess with that kind of stuff. Memorize the stuff you know. Minimize it. You have calculators, so we don't care if you have an extra step. All right, this is a good one. Make sure that you do this in your calculator. Let's see, what time is it? Oh, yeah. So try these. 9, 10, 11, 12. Try these. And then we'll go back and do some algebra. Probably pick the ugliest one. If you're not sure, just ask. So, well, maybe you don't even remember those prefixes, right? We should write them somewhere. Right, if we started with milli. Yeah, let's do everything in terms of grams. So these are the main ones, if you don't remember your prefixes. Right? The number always goes with the prefix except for kilo. to do this stuff? No? Okay. So just start with this. All right, 7.38 times 10 negative 22 cubic millimeters. Right? And then just millimeters to meters, and then meters to decimeters. And you just got to cube them, though. So millimeter has to go down here, though. So there's 1,000 millimeters in a meter. Right? But that's the 1,000 of them. And then you got to cube the whole thing. Okay. Now you're in cubic meters. So then the next one, a meter is 10 decimeters. That would be 10 decimeters. And then you got to cube it, though. And then you're done. And then for this one, the trick, I think, is just realizing that seconds is in the denominator and hours is in the denominator. So you got to convert meters to kilometers and seconds to hours. But definitely you have to know these. Otherwise, they're going to kill you, right? So there's 100 centigrams in a gram. That should be a C. Yeah, definitely know these.
What jumps for 36 meters per second?
So a minute is 60 seconds.
Oops.
And then 60 minutes in 1 hour.
Right.
60 minutes in 1 hour. And then do MIN instead of M, otherwise it looks like a meter. And 1H. There you go. So 60 times 60 is really 3,600. That's where I got that 3,600 from.
Okay.
Word. All right. Oh, one other thing you got to realize is seconds has to be up on top. Otherwise, it's not going to cancel. Yeah, because your seconds is down here. So right in the /s is a killer because you don't recognize it's on the bottom. So the box thing really helps because it's going to realize, okay, top units, bottom units. And it helps you cancel them. Did you catch that, Kelly? Yeah. Yeah, density has to be in standard metric units.
What's a Pascal equal to?
Force, sorry, pressure. Pascal's pressure. So pressure was force per unit area. So put the units of force in and the units of area in, and you'll have a Pascal.
Wait, it's in kilograms, right?
Density?
No, density is grams per milliliter.
No, density in standard metric units.
It's kilograms per milliliter.
Kilograms per, so think of it this way. Density is what over what? Mass over volume. So So standard metric unit for mass is kilograms. For volume, it's meters cubed. Didn't we do pressure earlier? Kilogram meter squared over second squared. What are the standard metric units for G? Did anybody get that far?
Wait, I thought pressure was kilograms over meters.
Oh, I copied it from. Didn't we get that? Or did I copy it down wrong?
No, right there.
Oh, it's right here. Kilograms meters over second squared. Did I screw up, Shelby? Oh, I screwed up big time.
It's the squared.
It's on the bottom.
Yeah. Thank you very much. Okay. Little g is what? Gravity, meters per second squared. And then I need h, which is just going to be m. So it should work out, right? Okay. Let's see. Now, a big reason for this, for doing all this algebra and math stuff, and the answers purposely aren't in there. So, because it really helps for you to be talking and explaining things to other people. And Alyssa and Eric, hold up these big honking calculators. What is the trick to using these things? Parentheses around what? Everything. And you're going to be fine. Okay? Parentheses. Yeah. But parentheses around everything. Okay? I've lived my life with this, and I'm very happy with it. Life is much simpler with this. Life is much simpler. But if you like your big ones, fine. Okay, now Jeff does not have anyone's number though, right? Does everybody have everybody's number? I don't think Jeff has anybody's number. All right? So now's a good time to share some cell phone numbers, right? If you don't remember your general physics, I